Okay, can you see
Oh,
the presentation?
yes, yes.
Okay. Good morning, everyone. Thanks for inviting me. I am Nicolo Anselmetto, a PhD student in forest landscape ecology at the University of Turin. Today, I'm going to present you the results of three studies that we carried out on the same subalpine watershed of the European Alps, where we integrated historical ecology and land use modeling to explain the current landscape structure and patterns of change. The current structure and composition of a forest landscapes result from several drivers acting synergically, such as abiotic factors like climate constraints that prepare the floor for biotic interactions, both positive or negative, dispersal and movement, and of course for the long-lasting effects of human activities, the so-called land use legacies. Interestingly, we can derive information on the history of land use, adopting historical ecology tools and methods from the current situation. And then, using information and data on the past and the present, we can also develop scenarios for the future, adopting, for example, land use change modeling approaches. What we did in this study area was exactly this. So ecological investigations allowed us to reconstruct the history of the landscape and future scenarios of change starting from the current conditions. Specifically, our main aim was to reconstruct the past, explain the present, and predict the future of this subalpine watershed of the Alps. Therefore, I will divide the methods and the results into past, current, and future sections. Concerning the past, which we consider from around 1400 to 1850, we try to reconstruct the historical mining production to identify the effects of this practice on forest structure and species composition. The current period consisted in the last 60 years, around the last 60 years, where we tried to determine the impact of recent land use legacies and recent land use changes on the new forest stands originated in the last 60 years. Finally, until 2100, we predicted changes, trying to disentangle the role of climate change and land abandonment for the next future. Okay, our study area is called Montavic, is a natural park located in Aosta Valley that is an administrative region in northwestern Italy in the Alps. The watershed area is around 5,500 hectares. The climate is alpine, with annual average temperatures ranging from 1 to 3 degrees and an annual precipitation from 800 to 1200 millimeters per year. Precipitations are mainly concentrated in spring and autumn. Concerning the topography, the catchment, the study area ranged from 900 to 2,500 meters above sea level. And the area is characterized by very steep slopes and a harsh topography, as you can see from the mean value of the slope. From the lithological point of view, this is really interesting. The area is really interesting and very studied because it belongs to the Montavic ophiolitic complex, where serpentine prevails. For this reason, soil fertility is very limited and many heavy metals are present in the soil. Mountain pine is the most abundant species in the area. Together with the European larch, they dominate the upper part of the watershed, that is this part over there, while broadleaves, especially beech, and Scots pine dominate the lower part of the valley. Due to the topographical and lithological constraints, historical pasture can be considered low. This is not common for the alpine space because many mountain watershed had a very high a very high pass-through pressure. In this case, however, the area experienced a high intensity of charcoal production, which is typical of mountain dominated by broadleafs, but rarely described in conifer stands, such as Montavic. Okay, concerning the methodology, as you understand, this presentation embraces a multi-scale and integrated approach. So I will give you not all the details. I'm here for your questions after the presentation. I will give you a shallow presentation of the methodologies in order to present the results. To analyze the historical charcoal production, we used a LiDAR-derived digital terrain model that had a resolution of 0.5 meters, along with a random forest classifier to detect relic charcoal hearts that are the platforms where charcoal production occurred. Starting from the DTM, we derived the slope map, which we filtered to have a better, to improve the segmentation and the classification with a 7-pixel disk, with a filter of 7-pixel disk. Then we did segmentation and classification with a random forest. We used the 665 objects for the training and validation dataset, including the 212 ground validated relic charcoal hours, where the position was taken with a GNSS receiver, and 453 visually interpreted non-RCAGs objects. In 125 of these 212 relic charcoal hearts, we performed 3 randomly distributed excavation of 10 by 10 by 10 centimeters, from which we obtain 1 liter of soil for each relic charcoal heart. As a result, we taxonomically identified with a microscope a total of 400 charcoals, which we used to derive the information on the historical species forest composition. Okay, concerning the methodology for the current analysis, for the present analysis, we started with 5 different aerial photos spanning more than 50 years from 1965 to 2017. First, we classified these maps in 5 different land cover maps using 5 land cover classes that are dense forest stands here in green, rare forest stands in light green, comprising also the shrubs, then grasslands here in yellow, unvegetated soil in green, and urban soil in red. For example, this is the 2017 map. Okay, then we quantified the changes on this landscape and the landscape metrics. Finally, we used these maps to detect new forest stands that are forest stands that were not present in 1965, but are present now in 2017. Here, we analyze the abundance of seedlings, saplings, and adults. Okay, moreover, we conducted another field campaign to derive the current forest structure and composition of the entire watershed, in order to compare this information to the one obtained from the relic charcoal arts. Finally, we specially interpolated this data through a simple inverse distance weighting algorithm. Concerning the future methodology, you can see the conceptual workflow for the modeling on the left. Long story short, we integrated 2 models, a Markov chain model for the quantification of change, and a neural network that is a multi-layer perceptron for the allocation of change. The multi-layer perceptron calculates the suitability of change according to the land use maps for the past and the present, and a set of driving variables. In this case, we use the topographical variables such as the elevation, the slope, the aspect, and so on. Anthropic variables such as the distance from buildings, the distance from roads and from settlements, and ecological variables such as the density of the forests and so on. As a result, the resulting scenarios can be considered business as usual since they show the continuation of past dynamics. Okay, now the results. Starting from the past, I just remind you the question was, what are the effects of mining on forest structure and composition? On the left, you can see the map of the detected charcoal kilns, of the detected relic charcoal arts. We detected 744 charcoal platforms with a density of 0.5 per hectare. And just to give you some insight on the exploitation of this landscape, that I remind you is very it has a strong topographical and lithological constraints, but however, there are a lot of charcoal platforms. And imagine that we found charcoal platforms at 2,300 meters above sea level. It is in this area here, where the vegetation is very, very limited. So what are the effects of these heavy exploitation of resources and forests? Concerning the species composition, we observed an increase in the mountain pine that already dominated the watershed in the past, but now it expanded to a 75% as a proportion of species. This expansion is to the detriment of late Syrah species such as beech and particularly spruce, that is now really rare and very, very limited, just sporadic. Concerning the forest structure, we observe mountain pine, that is here, Pinus uncinata, associated with a very high density of relic charcoal arts in cooler slopes and steeper slopes. Instead, the larches are associated with a low density of relic charcoal arts in gentler and hotter slopes with higher diameters. Regarding the recent landscape patterns of change, so concerning the last 50, 60 years, we observed the first stage from 1965 to 1975 with a stability of dense forest cover that you can see here, followed by a rapid gap filling of abandoned meadows, because here in these remote and marginal areas, we have a very strong land abandonment of traditional land use. So from 1975 to 2006, dense forest cover increased from 1,800 hectares to 2,800 hectares, with a gain rate of 2% year. In the last years, we observed the saturation of the available space and the lower rate of forest gain. On the right, you can see the special process from the aerial photos. So these are the lower elevation. Concerning the upper elevation, instead, we observe the woody and grass encroachment on unvegetated areas. Here, the main landscape dynamic is the decrease of unvegetated soil, especially in the last 20 years. This strength in the last years of encroachment in unvegetated areas may be evidence of climate change. Also here on the right, you can see the spatial process. Okay, what are the effects of these recent changes on the forest structure of new forests from 1965? The graph shows that mountain pine dominates almost everywhere, especially in forest stands originated from unvegetated areas, while larch is usually dominated, especially as sapling and seedling. The only legacy where larch appears as the main species is one that you can observe here from the abandoned grasslands, especially abandoned pastures and meadows, where large larches, also present in 1965, acting as seed sources, were present in these past cultural landscapes. Okay, our last question regarded future patterns of change and the interplay between land abandonment and climate change. As we can see from both the maps on the left and the graph on the right, the area of dense forest is expected to increase in the future. You can see the high proportion of dark green, especially in the upper part of the valley, that is here on the right, on the left, and in this bottom part. From the modeling, the lower part appears as fully saturated. You can see that grasslands appears to remain in the future, while the upper part is expected to experience the first stage of grass encroachment, followed by shrubs and then trees. This is probably the result of the continued utilization of lower meadows that you can see here in the bottom of the valley, and the effect of climate change on the upper part. Okay, now I'm just trying to synthesize everything in the discussion. So between 1400 and 1850, the valley experienced intense mining activities, especially on two main blast furnaces sites that are La Serva and Perrot. Moreover, due to the climate of the area and its remoteness and the harsh topographical and lithological conditions, pasture pressure was low. The interplay of these long-lasting socio-ecological conditions resulted in the expansion of light-demanding pioneer species, especially mountain pine, favored by short-term clear cuts, 30 or 40 years of clear cuts each 30, 40 years, to obtain small pieces of wood to fuel the furnaces. Nowadays, relic charcoal hearts are still visible under the forest canopy, especially in pine stands. Larches are instead associated to abandoned pasture sites and dubs in sunny and gentler slopes. Spruce and beech are the two late serial species that suffer the most from the historical land use. They are, in fact, they decreased in favor of the pioneer species, light demanding pioneer species. Especially beech suffered the most, probably because this species is at the edge of its ecological range. From other analysis, it is interesting to note that we observed 50 years as a time required for abandoned relic charcoal hearts to be colonized by trees. This is the difference in age between trees outside the platforms and trees inside the relic charcoal platforms. Concerning the last 50 years of change, we observed a great land abandonment, resulting in a general forest increase. Especially, we observe two different patterns of change. In the lower part, at lower elevations, we observed gap filling and homogenization of the landscape with great saturation of the available space. In the upper part, instead, we observed a forest increase, but that resulted in landscape fragmentation and tree encroachment. Recent legacies confirm that larches are usually associated with abandoned pastures and meadows, where the land use legacies consisted in grasslands, especially as seedling and sapling. Instead, mountain pine dominates almost everywhere, especially in the young, as young individuals. So in the future, it is expected to rule also in the next years. It is important to note how the general increase in the forest cover in the Montavic that followed the land abandonment resulted in an increase in the abundance of some bird species, such as the great spotted woodpecker that you can observe here, and the pygmy owl, that is a rare, very rare species that surprisingly is considered an indicator of old growth forest conditions. And as you can understand, this area is no old-growth forest for sure. Okay, regarding the future of Montavik catchment, the business as usual scenarios enhance the current trends of land use change, showing an expected increase, especially in the upper part of the valley, where, as you can observe, larches and mountain pines are expanding throughout the landscape. Even if they show the continuation of trends, business as usual scenarios are particularly interesting in informing park managers of the threats and opportunities for conservation. Of course, this approach does not include a set of drivers of change, such as the limited fertility of the soil that may slow the rate of the initial primary succession. And also, climate change may not result just in gradual changes, but also in abrupt disturbances, such as extreme drought. So thanks for your information. Here on the above, you can find the references for the 3 studies that I tried to join today in my presentation. Thank you.
Many thanks, Nicolo. Very interesting, your presentation. I think it's part of your PhD dissertation.
Yeah, it is, because my PhD is in modeling forest habitats concerning climate change and land use change. So yeah, this is one of the part.
Great, great. Well, for the moment, there is no questions here in the chat, but I have one question. You mentioned landscape metrics in your analysis.
Yeah.
And I would like to know which landscape metrics do you use?
Okay. Yeah, we analyzed for example, the interspersion of matrices and patches, the density of edges, so the edge density, the Shannon evenness to understand the evenness of the distribution of the different classes, and also the proportion of patches, of different patches in the landscape. So thanks to these metrics, we understood that the lower part showed an homogenization, a very strong homogenization. I didn't put the graphs here, but you can see that there is this absolutely huge matrix of dense forest, while the upper part show a fragmentation. So even if the trend is the same, the dynamic is the same, the land abandonment, climate change leads to forest gain, there are 2 different patterns, very interestingly showed.
Okay, many thanks for your response. Here there are some questions from Solz Molnar. What do you think is making people to switch to other land uses? For instance, what made people to abandon mining or livestock in the past?
Okay, thanks for the question. This is really interesting. Of course, when analyzing heavily exploited landscapes such as the Alpine one, as I said, there is a lot of socio-ecological drivers. So not only the harsh condition of the soil and the topography, but also really, really important socio-economic drivers. And for instance, people abandoned mining activities, especially in the 19th century, but they continued for home production, let's say, also in the 20th century, but they abandoned this traditional use, especially because of the globalization and the change in the economic perspective. Let's say that from the 20th century in the Alps, we passed from a local and micro scale production based on the family and so on, to a developed and current situation of economy. So there was a very intense rural exodus from the mountains and rural areas to the cities. And of course, this resulting in the abandonment of these practices. Regarding the livestock, as I've said, this area was not particularly vocated for grazing and pasture, and so there was quite a low pressure also in the past, but now is really, really, really low. The only activity that persists is tourism in the valley.
Okay, many thanks. There are some more questions. People is animated in this lecture. Was there any change which tree species formed the upper tree line?
Sorry, can you repeat? Are there any?
Yes. Was there any change which tree species formed the upper tree line?
Okay. No, we are also analyzing this tree line, this particular tree line of the park, along with other 9 tree lines of the Alps. But I don't think there is a change in the species. The 2 main species are larch and mountain pine. Of course, it can be that in the past, before the heavy exploitation, also spruce was present, but as I told you, spruce was really, really, really disadvantaged by this intense exploitation. So concerning tree species, I don't think there is a great change. Concerning shrubs and grass species, I don't think so either, but just because the limited fertility of the soil in the area already drove to a limited species richness.
Okay, there are more questions. Engine questions is, what are the driving variables for the scenario land change modeling process?
Okay, for the land, thanks for the question. So for the process of modeling, for the Markov chain part of the modeling, the only input variable is the only input variables are the land maps, the land cover maps. For the multi-layer perceptron, so for the suitability of change and the allocation of change, we use the land use cover maps, land use and cover maps. So the land cover from 65, 75, 1998, 2006, and 2017, along with a set of ecological variables, such as the distance from the forest edges, the density of forest stands, the suitability to change, the probability to change from one class to another, then a set of anthropic variables, especially the distance from settlements and buildings and from roads. We took this information from OpenStreetMap, so from the layer of street and buildings from OpenStreetMap, and the cost of movement, that is the time required for a person to walk through the landscape starting from a building. And we used also a set of topographical variables extracted from the digital terrain model, such as the elevation, the slope, the aspect, and the heat load index, and the ruggedness and roughness of the area. I think these are all the variables we used.
Okay, many thanks, Nicolo. I think we have done all the questions for now. And okay, many thanks for your lecture.
Thanks.
And we will continue. Okay.